Hi, I'm Anil Nanduri from Intel. I'm the Director of Products and Marketing at Perceptual Computing Group that makes all the Realsense technology. Okay, what we wanted to show you right now is all the devices that are in market with Realsense technology. Wanted to give you a sneak peek of some of the interesting applications that are coming and are already, many of them are in the market already, and some of them are coming into market, and show you the amazing things that the 3D technology can do in a PC form factor or an all-in-one form factor. In this use case, we typically tend to call the camera as a user-facing camera. So in this scenario, you expect the camera to work in about a 3 feet personal zone where the user is sitting up close and personal to the computer, and he's interacting with the computer like he would normally do. And there are many interesting cases where the 3D camera starts to apply. The first case is that, okay, the first thing you do when you get to a PC is to log in. What the 3D camera can now do is, because there's a 3D depth map it is taking, a camera like this. This is what we call the Realsense 3D camera F200. This is already launched and is in market. We have almost 25 devices in market today and more coming with Skylake platforms. Now, with this, first thing you want to do is be able to see how you can avoid having to type a password. The depth map and the 3D mesh that you have of a person helps create a very secure way to authenticate yourself to the platform. And because there's infrared in the system, it also works in very different lighting conditions. And so the capabilities of the Realsense technology is what enabled Microsoft with Windows 10 to enable face unlock with the Windows Hello feature. So it's a very secure way to unlock the capability. We also support the same capability with the Intel TrueKey software for not having to have passwords. So imagine the ideal world of having a time where you don't need to remember your passwords and having a very secure way that you feel comfortable that is authenticating you. The Realsense technology can enable that. So that's the first kind of a use case where this technology can help. The next thing you want to do is, a lot of people use video conferencing. Now, video conferencing has this, quite often when I'm trying to call my mom up, or my mom wants to do a video conference with me, I'm like, wait a minute, give me 10 minutes. And the first thing I'm doing is cleaning up the bed behind me, or moving up the laundry, or cleaning up the clutter in the house. Quite often you don't do video conferencing, not because you don't want to, but because the environment you are in doesn't feel suitable for you. Another situation where you sometimes end up is that, hey, you are in your office and you're in a confidential environment and you don't want someone to see what's behind you. You're in the front of a lab, or you're in front of a factory, and you don't want someone looking at, or a whiteboard where there's very extremely financial information. You don't want people to see what's over there. And then in some other cases, it's about you yourself don't feel comfortable because you didn't have a shower or you did not shave, and you don't feel like you want to present yourself in the video conferencing. Now, with the 3D technology, with Intel Realsense 3D technology, what we can do is extract the person out of the background, which means that I can change the background to whatever background I would like to do. I could also interact with an avatar real time, and versus having the other person see me, I can present an avatar, a 3D avatar of myself, and I can control the avatar, so to the person on the other line is actually talking to my avatar and not really looking at me with my unshaved look. So all these kinds of use cases is also possible. Now, a use case like Twitch, where video streaming and for gamers is a very huge application. Now, with things like open broadcasting software, a lot of people today use a green screen for broadcasting. So they like to have their own private green screen. With the 3D technology now, you can actually take the person off, not need all that complicated equipment to do the green screening, and you can do it right in front of sitting of a laptop. So we're going to show you some of those examples through a demos in the next few minutes. So what Nicole has here is a video conferencing that you typically do today. This is what Nicole is. She sees the background. I am here, and you have this little hotel room that we are in where we are doing this video shoot. Now, what Nicole can do is she has the Intel Realsense technology-enabled PC here, and with that, she can do some interesting magic here. The first thing she can do is hide the background. So now Nicole is in a field, so you can't see me anymore, though I am right here behind. If you want to toggle back and forth, Nicole. No. There you go, that's me here. And there I'm gone, right? So this gives you a very secure and private environment. You don't have to show what's behind you, and you can be at home, you have clutter of a bedroom behind you, and you don't have to worry about other people seeing you. Okay, now interestingly enough, Dimitri, who's chatting with Nicole on the other side, okay, he didn't shave today, or he feels he's not comfortable enough to do a video conferencing, so he doesn't want you to see him. So what he would like you to chat with, he wants to chat with an avatar. So what we have here is, obviously this is us, Nicole and myself, but Dimitri has actually transformed himself to an avatar mode. And he can talk. Dimitri, can you blow a kiss to Nicole? Can you close your eyes? Can you raise your eyebrows? So this is real time happening on Dimitri's side, and he is on the other laptop, as you saw earlier, chatting really through Skype interface. Now Dimitri can become a robot. Now he seems to be in a grumpy mood, and so he wants to be someone more mean. Or how about this, an orc? So all these are, at a click of a switch, he's able to change these avatars and to choose. So imagine the possibility of not only having your own avatar, you could also choose any different avatars you would like to, have as part of your conversation. And by the way, Nicole now can change the background, and she can hide the background first. And now she can be in space, or in the field, or in the snow, or at the beach. And she could be at the beach and saying that she's at work. So what Nicole is interacting right now is with Face Shift. It's actually an avatar control application. So she is actually controlling this avatar real time and being able to blink, close her eyes, raise the eyebrows, blow a kiss. And because of Intel Realsense 3D camera, you could do this real time, since the camera has ability to track different elements of the face, as well as be able to run at 60 frames a second. And you can change avatars by hitting this, or you could be this, or you could be this. So this reminds me of the character in Men in Black.
It does. Yeah, it really does. I like how his ears flop.
Yeah. All right, so that's another application that's coming to the market. This is not launched yet, but Face Shift is working towards bringing this as a product for end users. So using the Realsense technology and the F200 camera that goes to PCs and all-in-ones, we so far talked about two of the key usages. One is about secure face login, so you can log in without having to type a password. The second one was about video conferencing and extending it to online gaming, sharing, and including avatar chat. The next thing that the 3D technology can also do is can do very amazing 3D scans. You can actually scan yourself and insert yourself into very interesting characters. And what we're going to do now is actually have Nicole scan herself, and we will choose her the character that she would like to be, and we're going to do that in a minute. And we took a 3D scan of Nicole, and this is Nicole in 3D that we just did here just a little bit earlier. And you can also see her earrings and the fine features and accuracy. Now this is in a mesh lab. This is actually a 3D mesh, so you can actually print this and it is not a stitched photo view. This is actually taken with the Intel Realsense 3D camera with a real depth map. This is what the video conferencing can extend to with the 3D technology. Now, it doesn't have to stop here. So this is how we do video conferencing, but a lot of people do gaming and use social sharing and being able to interact with online content. So using the Realsense 3D technology, I can also enable the experience in a gaming interface. So what Dimitri now has is he's actually segmented himself off the background, and he's actually playing a game, and it's running with the open broadcasting software. So this can actually be streamed without the need for a green screen in front of the PC. And you can also have multiplayer gaming where you could all be playing online poker, and you want to have to see them as well as not just play the cards. You can actually share with your friends online, and you could have all your bobbleheads real time watching the expression as you play poker and lose a hand or win a hand. And what you have to do is just use your head to actually navigate. And and there are some ramps that show up, and then you jump into the sky, and then you also use and there's a ramp. No, okay, there's a ramp. Yeah, now he has to collect coins. Now he uses his hands.
Oh, fun.
Yeah.
So what we did was, as I talked about the usages for the camera, the Intel Realsense 3D camera for the PCs and all-in-ones, for secure unlock, for video conferencing and extending it beyond collaboration, as well as avatar chats, also 3D scanning and sharing, and you can also print those into different characters. And last but not the least, gaming. And every new technology, there's a lot of fun ways to interact with gaming. So we got a wide range of games from Lego to DreamWorks with their Move It title. This is the King Julian from the Madagascar series. So we have many more games in the market. In fact, we're tracking over 65 applications coming towards this year into the market. Quite a few are already available. You can go to www.intel.com/realsense. You can see what devices are in the market, what apps are available, and all the capabilities of Realsense technology all available in one-stop shop. So now we talked about the PCs. Where we want to go is into tablets and the mobile form factors. So what we want to go and show Nicole is that these are devices yet to be launched, and we are tracking towards bringing them out later in the year. And we can show you when you take a 3D camera and put it at the back of the tablet, which sees the world around it, what you could do with it. Let me show you what the example of a camera is. So we have two different camera technologies. This is the camera technology we spoke up until now. This is what goes into the PC. It works about 1 meter in range, which is about 3 feet or so. It actually has fine gesture control. It can track the full hand skeleton of a person, and does the video conferencing and other use cases that I mentioned earlier. We also have this other camera technology. This is what we call the Intel Realsense 3D camera R200. This is targeted for mobile devices, including tablets. This works longer range. It also works outdoors. What we're going to show you is some of the examples where now when I'm in a mobile form factor, I can hold it and I can scan around an object. I can scan around a person, so I can do a full scan of you, and I can also scan the room and the environment around us. So why do I need those? What will happen is with these, when you have depth sensing capabilities in a tablet, you can bring new capabilities to the end user. First of all, a lot of people use tablets and mobile devices to take photos and videos. When I take a photo, I can use the depth information that comes from the Realsense 3D technology and then be able to then add effects. I can lens blur. I can give you a depth of field effect. I can do coloring the background, so basically keep the person in black and white and the rest of the background in color, or the other way around. I could also refocus on different people in the scene. Why? How can I do that? Because the information is captured as you take a photograph. You can also do this with video because the depth information is at 60 frames a second and video is at 30 frames a second. I can apply the same filtering and think of it as Instagram for videos. How cool that would be, make a video that you take and make it look like a cartoon. So you can actually do that with the depth camera technology. We can do 3D scanning. As you know, the 3D ecosystem is becoming very prominent. People would love to see objects in 3D. The whole world is in 3D. We see, as humans see in 3D, if you give that same capability to the compute devices as well, you can now scan the world in 3D. You can scan your room, you can redecorate it. You can see how often do you go to a store like an IKEA and wonder whether that piece of furniture will fit in your house. Because of the 3D technology, you can have accurate measurements of your room, and you could be out there and saying, wait a minute, let me see how does it look in my room, and it can actually do those kinds of capabilities and use cases for the user. It can also do measurements. You can also, how often do you look for your measuring tape? The tablet or the phone in your hand could be your measuring tool. You could also do scanning people, and when I scan you in 3D, I can print, I can share, or I can also insert you into a game title. You can actually import yourself into a game. How cool would it be to play a game with my friends and us as the characters versus having an animated character that was pre-designed? So these are the kinds of amazing capabilities that the 3D camera can bring. So there are many times you like to measure objects and you always wonder, where is the measuring tape? I'm always, you kind of, oh, that looks like 2 feet, that looks like 1 feet. Now, if you had your tablet with you, which we always carry around, or a mobile device, I can actually measure real time. So what I'm trying to do here is, we all know that's a 13-inch laptop, but then, you want to know exactly, did you get 13-inch of laptop? And there you go, 13.23. It's actually a 13.3-inch screen there, and we could measure that real time. Now, but then that's okay, fine, I can see that and I measured it. What I can also do is I can take a picture of it, okay, and I can save the picture, and now I can actually, because the picture already has depth information, turn towards the camera so you can see it, okay. He's showing you, and there's the measurement. He's kind of didn't pick the right edge there. But this is just showing the technology. This is not the actual application. But the application then has all the UI and how to make it easy for the user. And you get what, 13.47? Yeah, that's about, he's gone a little above that. Now, quite often what happens is that, wait a minute, okay, I get that, but then I want to measure from this edge of the table to the other edge. What do I need to do? So what he's going to do is he's going to pick that edge. I'm going to say, okay, from that part of the table, keep in mind now the tablet's no longer seeing that side of the table, right? And he's come to this side of the table, and he can go back, and he knows that the edge is marked, and it tells you that's 56.98 inches from there to here, right? And that's what the 3D technology can provide to you, and it's also using the motion sensor inside so it can track the scene. Right. Again, this is the technology behind it. What the final application will be is taking this technology and making it into end-user friendly application. So JD.com had an interesting proposal, was that they want to be able to measure objects as they come through. They also want to measure boxes as they go through their warehouses. So the Realsense capability brings very fine measurements and very accurate measurements. It can also tell you what size of a box you can pack with on a certain object, or you can measure the size of a box as it goes. So one of the interesting things is that quite a few times when during transportation and logistics, it's very difficult to know how to stack up different size boxes most efficiently into a truck or into a container or into some kind of a pallet. What this gives you is the ability to measure all these boxes up front, and I can show you a demo later, and then be able to then figure out and computers can run the algorithms and do the stack up and say to the user, saying just put this box first, put this box next, put this here. It can guide the people as they pack how efficiently to pack. So a lot of interesting use cases around this. JD.com is a great partner. They want to be able to measure through their warehouses as well, and wanted to use Realsense technology with it. So what Dimitri is showing now is how we can measure boxes. And so there are some boxes on the table here, and just pointing it to it or changing to a different box, you can see how it quickly tells you what the box size is. And the interesting thing about this application is also, once you measure the box, you can also take quick pictures of it, which saves the parameters of the size. And yeah, that's fine. And tells you how you can stack it. As we add more boxes, it tells you how to put, the stack of the boxes more efficiently. Now that's all in software, so you can run different kinds of algorithms based on how you want to stack it. You want to stack it for volume, you want to stack it for, put all the big ones at the bottom. So now the computer softwares can decide, okay, based on the situation or the scenario, what the user wants or the business wants, what kind of parameters of stacking they want to use. But the key thing is that you have all this data for you to use. Also, before you even get to that airport, the airlines have information how to load up the plane and then load up the cargo because they could measure everything. So that's the future at some point, where everything's done ahead of time and you just show up and everything's packed and ready to go. Now, sometimes you also want to scan the environment around you. So we want to scan this room. So just like you kind of do a little spray painting, you just have to point the tablet across the scene, and what it's doing is real-time constructing that in 3D. And then he can pause it, and he can show you that that's indeed the 3D model. And as this is a very, very pre-alpha version of the technology, but when we get this to the market, you'll actually be able to then use this information for scanning in your rooms and other. We always like to play fun games with any device, and that goes with a tablet with a 3D camera as well. So what Dimitri has done here is actually brought a little robot to interact with the table that's in front of us. Okay, but then I feel like driving a car, so he's going to swap it and say, okay, but what happens in the real world? Oops, that's the edge of a table, right? So the car should fall off. That's exactly what it does. And then how do I cross over from that edge to the other? And oh, by the way, before you jump into it, I would like you to show how it can hide behind a box. Okay, so if you put that helicopter over there.
Oh, yeah, there it goes.
Yeah, so if it's behind the box, hold it. Can you go over to the other side? To the other side and show the angle from behind the box. And like a real world, you're not supposed to see it, and you don't see it. So it's occluded by the object in front. And why you can do that is because you have the depth information. Okay, now you can see the shadows. You can see, even the helicopter can go off the scene.
Wow.
He can go off the scene and bring it back in. And it's still flying over there, and you can bring it over there, you can see, and he's bringing it down there. Okay, and now if you go back to the robot, and he's come down, now you want to jump off the edge of the table, and he'll fall off the table. Right, so that's how it's meant to work in the real world. So imagine how your room or your world around you now becomes the environment for the game itself. Again, this is a concept. This is not an end user game, but the idea here is to show how this capability of a depth sensing Intel Realsense 3D camera can help. So as you can see, we talked about the PCs, but this camera goes into tablets, and we showed some of the capabilities, what you can do in the tablets. Moving forward, you'll also see these in phablets and phones. This is where the capabilities of the Realsense 3D camera could also be used. But we don't stop there. These are all the compute devices for consumers in the client space. But because of these camera technologies have a lot more interesting applications, they work outdoors. One of the biggest problems in the ecosystem for drones is about safety and collision avoidance. It's an unsolved problem, and a lot of people are really trying to do that. But with Realsense cameras, you can actually put it on a drone, and now the drone can see. And so you're bringing the human-like vision to the flying systems as well. Now they can see trees outside, they can avoid them, they can see buildings, they can see people, and they can decide how much far away from them they have to be at. So those kinds of opportunities now Realsense technology can bring. Even with robotics, where you want to navigate and you want to be able to go around your house or in your office environment, self-navigating robots now with the capabilities of depth sensing become a reality. There are many more use cases where anything well, from the factory automation to interactive kiosks to robotics to drones, all these where Realsense and depth sensing technologies can apply. What this world would look like in future would be where the human computing interfaces would become more natural, they would understand us better, and they would actually assist us in making our lives better. And I think that's the wonderful future. And to do all that, you do two things. First of all, you need to give the human-like senses to these systems, and vision is one of the key elements of how human-like sensing comes to this technology. And the second one is you need to have compute. And with the advancement of Moore's Law and the 50th anniversary of Moore's Law, what's really happening is that that computing performance that you're getting into the form factors to the size of a Quark processor and Edison processor, those in future in wearables, headsets, virtual reality, augmented reality, that computing with the combination of these human-like senses brings this technology and the use cases to life.